Alright, so this is how to find the inverse of equations. This was a little more tricky example because it's rational and there's x in both the numerator and denominator. It's not difficult, it's just a little bit trickier than most normal inverse functions here. So inverse, you just know you switch x and y, then resolve for y. R of x, so again the r function with respect to x, is just a fancy way of saying y, so I'm just going to rewrite it here. Alright. Then we need x and y to switch places. So here, watch this. So I get x equals 4y over y minus 3. So notice how both x's on that side change positions. Okay? So that's why it makes it a little bit trickier, right? Because you had to replace both of the x's. Alright? So I'm going to put an invisible 1 under x, which reminds me that a fraction equaling a fraction, I can do cross multiplication, and I make a beautiful butterfly. Alright, so that would be 1 times 4y is 4y. And then x times y minus 3, I'm just going to write them next to each other. X times y minus 3. So notice how I have y on both sides of the equation. So you might say, oh, we'll just divide by y minus 3. Except, we need to be out of the parentheses because remember, we have to get a single y by itself. So this is where it gets a little tricky. I'm going to go ahead and distribute the x here, so that gets rid of the parenthesis. So 4y equals, again, xy minus 3x. So remember, we want to get y on one side. That's my goal. I want to solve the equation for y. Everything else on the other side. Well, so 4y is already on the left, and usually we like y on the left. So I'm going to subtract xy to the other side here. Now, you may have seen this before. If not, then this will make a lot of sense once I explain it here. So I have 4y minus xy equals, I have a negative 3x on this side. Alright. So, notice how now I have a y in this term and in this term. I could factor it out, leave me with 4 minus x. So see the genius of what I just did there? So I moved the y's on the same side, and because both terms had a y in it, I could factor it out so that I can get y by itself. So now I bet you can see what to do here. Divide by 4 minus x on both sides. 4 minus x. And then y equals negative 3x over 4 minus x. So if you made it here or you were able to do this all by yourself, fantastic. That's like 90% there. We just need to clean it up. But I can write it like so. R negative 1 of x, that's how we signify inverse. So this is the inverse of the r function is equal to negative 3x over 4 minus x. So you might notice in the denominator, that's weird. Usually the variable goes first, right? Well, in this case, there's another way of completing this. So we write the positive term first. But I actually am going to write the negative term first here to help you explain what's going on. So this can become negative 3x. And if I just switch negative x and 4, it would be negative x plus 4. But notice how I have a negative both on top and bottom. But remember, we have to factor out the negative, not just get rid of it. So if I factor it out of the bottom, it's negative, and then x minus 4. Now I can cancel out the negative both top and bottom. So this would be my official inverse equation there. Again, if you stopped here at this point, that's very good. But this would be like, oh, you actually understood there were negatives involved and canceled them both out. So when we graph the inverse, it's a little bit more clear to see. All right, so that is how we find the inverse of that equation.